sklearnmetricsgetscorer. Description: the getScorer function in scikit-learn provides a convenient way to obtain a scoring function that can be used to evaluate the performance of machine learning models. It acts as a wrapper around various scoring metrics available in scikit-learn. Inputs. Scoring: this is the primary input, specifying the name of the desired scoring metric. It can be a string representing a standard scoring metric, or a callable function that implements a custom scoring metric. Common string inputs include accuracy, precision, recall, F1, ROCOC, R2, etc. Quarks: additional keyword arguments that can be passed to the scoring function. These arguments are specific to the chosen scoring metric and may influence how the score is calculated. For instance, for metrics like F1, you might pass average macro to calculate the macro average across classes. Outputs. Scorer returns a callable object representing the scoring function. This function can be used to evaluate a model's performance on a given dataset. Steps. Parsing the input: getScorer first parses the provided scoring input. If it's a string, it identifies the corresponding scoring function from the available metrics in scikit-learn. If it's a callable, it directly uses the provided function as the scorer. Creating the scorer object, it then constructs a scorer object. This object is essentially a callable that wraps the selected scoring function, making it compatible with scikit-learn's model evaluation framework. Metrics. Accuracy measures the proportion of correctly classified instances, useful for balanced datasets. Precision measures the proportion of true positives among predicted positives, relevant when minimizing false positives is crucial. Recall measures the proportion of true positives among actual positives, important when minimizing false negatives is critical. F1 score: harmonic mean of precision and recall, balancing both metrics. ROC: AUC area under the receiver operating characteristic ROC curve, which measures the ability to distinguish between classes, used for binary classification problems. R-squared: R2 measures the proportion of variance explained by the model, useful for regression problems. Visualization plots. Confusion matrix visualizes the performance of a classification model by showing the number of correctly and incorrectly classified instances for each class. Precision recall curve plots precision against recall for different classification thresholds, providing insights into the trade-off between these metrics. ROC curve plots the true positive rate recall against the false positive rate for different classification thresholds. Fine-tune parameters. Average for metrics like precision, recall, and F1. It specifies how to calculate the average score across different classes. Options include micro, macro, weighted, and samples. Poslabel when working with binary classification. This parameter defines which class is considered the positive class. Sample weight allows for weighing individual instances during scoring, potentially addressing class imbalance or other data characteristics. Uncertainty methods. Confidence intervals can be calculated for various metrics to quantify the uncertainty in the estimated performance. Bootstrap resampling involves repeatedly drawing samples with replacement from the data and calculating the score for each sample. This provides an estimate of the variability in the score. Challenges and fixes. Challenge 1: mismatched scoring metric using an inappropriate scoring metric for the problem at hand. For example, using accuracy on an imbalanced dataset can be misleading. Sample use case that resulted in challenge 1: using accuracy for a fraud detection problem where the number of fraudulent transactions is significantly lower than legitimate transactions. Fixes to challenge 1. Select a metric that aligns with the problem's objectives. Consider precision, recall, F1 score, or ROCAUC for imbalanced datasets. Challenge 2. Incorrect parameter usage, providing incorrect or inappropriate arguments to the scoring function can lead to incorrect results. Sample use case that resulted in challenge 2: using average micro for the F1 score when aiming to assess the performance for each individual class. Fixes to challenge 2. Understand the meaning and impact of different parameters for each scoring metric. Refer to the scikit-learn documentation for detailed explanations. Challenge 3. Overfitting, selecting a metric that strongly emphasizes maximizing the score on the training data might lead to overfitting. Sample use case that resulted in challenge 3: choosing a metric that encourages memorization of training data, resulting in poor generalization to unseen data. Fixes to challenge 3. Employ techniques like cross-validation to evaluate the model's performance on unseen data. Use regularization techniques, e.g., L1 or L2 regularization, to prevent overfitting.